All right, so what we're going to work on today is we're going to take some information and we're going to enter it into tables in Desmos, and then we are going to look at the information and use it to try to decide what type of graph would best fit that data. Okay. Then Desmos is going to help us figure out an equation for that, and then we might use that equation to answer some questions. So this is, you know, as you can get. This is what people actually use this math for. All right. So let's start with, it says, what polynomial function has a graph that passes through the 4 points 0, -3, 1, -1, 2, 5, and -1, -7. So we're going to take that and turn it into a table of x's and y's. 0, -3, 1, -1, 2, 5, and -1, -7. So on the Desmos app, if you would open up a table and then enter 0, 1, 2, -1 in the x's, -3, -1, 5, -7 in the y's, and then when you have that done, we will chit-chat about what to do from there. Okay, so you hit the plus sign, and then that gives you a table. The x's were 0, 1, 2, -1. So 0, 1, 2, and then -1. And then the y's were -3, -1, 5, -7. -1, -3, 5, -7. Okay? What do you think? You got it? I messed up? 0. Oh, have those switched? Okay, thank you. Okay, so something like that. And I can't see that last point. It is right there. Okay, so the question is then that we have to answer is, what kind of a function would we use to match these points? Okay, and so let me get a little crazy here, and if I were to take these points and if I was to draw a line that goes through them, what is the end behavior of that line? Down, up. Okay? So if it's down, up, what do you know about the degree of the polynomial? It's odd, and then the lead coefficient is going to be positive, okay? So it's odd. So our choices for that are 1, 3, 5, 7, etc. How do you know it's not 1? How do you know it's not a first degree polynomial that's going to match? Because that would make it linear, and it's got a little hitch in its giddy up, so we know that it's not linear, okay? And so what we want to do then is we want to take the lowest one that's available to us. So we're going to go with third degree, okay? So to find the equation for the third degree, we've done this before. Are you ready? Okay. It's going to be y1 Then you go squiggly line from the keyboard menu. Kate, quit enjoying life so much. Okay. Then you have a x1, and you guys said third degree, so I'm going to go cubed. Okay, are you with me? And then I'm going to go b x1 squared. Oops, forgot the plus in between there. Sorry. Okay, plus, what's next? cx1. And then the last one is going to be plus d. Okay? And you could actually use any letters that you want for the A, B, C, and D, and it doesn't matter. It will give you values. The most important part is that you do a Y1 and an X1. Okay? All right. So, yeah. If you type an X and then you hit a 1 after that, it'll automatically make it into a subscript. So just go X and then 1, and then for the exponents use this is for squared, and this is for anything else. Okay? Okay. All right. So what they have come up with for us is the values of A, B, C, and D. You can see they're all nice whole numbers, and the r squared value is equal to exactly 1. So what does that tell you about how well the graph fits the point? 100%. Okay. So 1, -1, 2, -3. So 1, -1, 2, -3. That means that our equation is y equals, I'm not going to write it, but 1 x cubed minus, because the next one was -1, so -1 x squared plus 2x minus 3. Okay? So that is the drone that you're looking for. Can I go back to the what? All right. So will you guys try that again? Make sure you can get this on your own with these points right here. So then here's the nice thing. You can just go back up and change the values in the table. And hopefully this will also be a cubic. And then it'll just change that equation for you automatically. Okay? So change those numbers for me. See what you get. Okay, so everybody's got that. All right, so let's do another one here. This is the what a nice graphic. This is the milk production in billions of pounds from Wisconsin. Okay, and we're given for 1955. Notice the old school 1955 style milk bottle. Nice job, textbook publishers. 1980. And then 2005. Also notice that the sizes of the containers are getting larger as the milk production is increasing. Okay? Yeah, we still have the cartons too. Yeah, and in Germany, it doesn't have to be refrigerated either, does it? It's better, but it doesn't. Oh, the eggs are not refrigerated. Oh, right. Right. That's why. Yeah. For this next problem, they specifically tell us that we're going to use a linear model, okay? So that takes the guesswork out of the stuff for us. I'm going to switch this up on you guys a little bit because it makes it slightly easier. Instead of letting my first x value be 1955, I'm going to have the x value be 0, okay? And then the y that goes with that is 16.5. So we have to think a little bit. If 1955 is 0, what's 1980? Right, so then that would be 25 because it's 25 years later, and that y value is 22.4. And then 2005 is 50 years later, and that is 22.9, okay? So will you take those three numbers? And again, it's best if we keep using the same table in Desmos and then just changing it instead of making a new one, because if you make a new one, then you have to change these all to be x2 and y2, and that's kind of a pain, okay? So just leave the same table, change the values that are in there. 16.5, and then 22 point, yeah, the last one was 50, I believe. Okay, and then 22.9. All right, now just as a little topic of conversation, you can see that you could use a cubic for this, and it would fit all 3 points perfectly. But look how crazy those numbers are, okay? So what we're going to do instead is, since they specifically said linear, is I'm going to delete those first ones. And then I know that those are not, oh no, it said linear, so I need to go all the way to here. And I know that you guys usually are familiar or more comfortable with mx plus b, but I'm just trying to save myself a little bit of trouble. So in this case, it says the slope is 0.128 and the y-intercept is 17.4. So this would be y equals 0.128x plus 17.4 is the equation that we came up with for that. I believe you. Yeah, that's fine. That's fine. Okay, and then you can see this if we graph this, or if I zoom out, you can see that it does miss the points a little bit, and actually the cubic was 100% perfect, so that would have been better, but for whatever reason, they would like us to use a linear function for this one. So if I want to figure out what the milk production was in 2000, what value do I plug in for x? Someone give me some confidence that I'm not just having a personal one-on-one tutoring session with Max, that there's other people in this room that are also with me. What is the x value that I would plug in to find the milk production in 2000? Remember, we started 1955, we made to be 0. So what is 2000 minus 1955? 45. Okay, so I would plug in x equals 45. So will you do that right now? Will you go 0.128 times 45 plus 17.4 and tell me what you get? What'd you get? Well, they were, oh. You got what? 18.62? Okay, so two different options here. Kate got what? Tell me that again. Kate, tell me that again. What did she say? 18.62? No, this is a really good exercise. And what did you say? 23.16. Okay, which? No, no, no. I know. Okay, right. But I want other people to learn from your mistake. How do we know? How do we know that this answer is incorrect? 18.62. Right, because it's less than these two numbers, okay? And the production in 2000 should be somewhere around the 22 or 23 range, and so 23.16, it's okay, it happens. 23.16 seems like a more reasonable estimate. So that's really good. So make sure that when you get these answers, you're thinking about the reasonableness of that answer. Don't just blindly write it down, okay? Um, Yep, it should figure it out. All right, so this slide here mentions that if we'd have used a quadratic model for the milk production instead, it would have fit perfectly, okay? Why is a quadratic model not probably the best? Yes. Okay, without the value judgment, I'm going to skip to your second sentence and say, yeah, generally speaking, things tend to be produced more and more and more, whereas with this quadratic model, you can see it's going up and then it's going back down, and it's more likely that milk production would continue to increase unless something strange happens along the way. Okay? Right, mad cow disease maybe, or something like that. All right, let's do one more. This is cheese consumption. The average, this is a good one. This is real. This is the average number of pounds of cheese consumed per person annually in the United States. And you can see that back in the old days, you guys said that for your U.S. history class, you're going to talk about the recession, the Great Depression. So in 1940, so just after the Great Depression started, the people only consumed about 5 pounds of cheese per year. Now, 2001, all the way up to 30. So definitely a sign of an increase in wealth. Okay. Well, I mean, I just had pizza last night and had, over half of it. I'm going to finish it today. There's cheese in virtually everything that we eat. I had pasta the night before. That had cheese on that. Probably had a cheeseburger the night before. You know what I'm saying? Like, think about how much cheese you eat. Let's do that math. 30 pounds a year is how much cheese per day? What is 30 divided by 365? So it's only 0.08 pounds per day. So if I take that and multiply it by 16, because there's 16 ounces in a pound, it's just a little over an ounce of cheese a day. So if you just eat a little bit of cheese, you just put some cheese on your scrambled eggs in the morning, you put a slice of cheese on your sandwich at lunch, you know what I'm saying? We eat a lot of cheese in this country. Okay? We eat a lot of cheese in this country. All right, so before we enter these into our calculator, let's recalibrate these. I want to make 1910 be 0 again, so I don't have to put in all these big cumbersome numbers. So 1940 would be up 30, and then 60, 65, 85, and 90 close. 91. Thank you, Aaron, for making me feel like it's just not Max and I sitting in a room together having a chat. Okay, so 0, 30, 60. So 0. And I'm going to change this to 30. And then the next one is 60. And then I'm going to change this to, what was it, 65. And then 85 and 91. And then the amount of cheese we started with 4. And then the next year was 5, 8, 10. So 5, 8, 10. And then things went up pretty dramatically from 1975 to 1995. I'm just going to throw this out there. I don't know if this is true or not, but maybe this had something to do with a lot of fast food restaurants starting to show up. So you're getting cheeseburgers a lot more. So then we finished with 25 and 30. Okay. Fun fact is what you're supposed to say. Okay, for this one, they again specifically told us, hang on just a second, to do a cubic. So I'm just going to tuck this in front of what I had before. So I'm going to go ax1 cubed plus, I'm going to put the bx1 squared back in there. And then plus the stuff that I had before. So there is my cubic regression for that. You can see that it's close to perfect. 99%, 99.76% accurate. But to get that perfection, boy, those are some nasty old numbers. So I'm going to just kind of cheat. And I guess you guys can do this because you're going to be writing it down on your paper. So I'm going to put these numbers onto this screen right here. And so my equation would be y equals 0.1234092 x cubed minus 0.0068 x squared plus 0.1467x plus 4.043. Okay? All right. And then I would assume they want us to figure out what the cheese consumption would be for 1980, 2000, and 2012. So hopefully you guys understand that to do that, you just plug in the x values into the equation. Did it work, Max, to do that? Can you change this and say x1? Can it just plug it in there? There must be a way, don't you think? If I say x1 equals like 25, not so much, huh? I guess the other way that you can do it, which may be easier, is to just look at the graph, to trace on the graph. So if I want to figure out 1980, if 1910 is 0, what's 1980? 70. So if I go over to the graph and I just click on 70, then I can get the answer that way. Maybe that's a little easier way to do that than plugging it into the equation. Does that make sense? Okay. All right, and then the last thought question is, if I was to use this to figure out the cheese consumption for 1980, 2000, and 2010, which one of those answers would I feel the least confident about? I'm sorry, 2012. Which one of those answers would I feel the least? Yes. 2012. Yeah, how come? Wow, that's awesome. I wish that my microphone could have picked that up because that's, yeah, exactly right. The numbers are changing really drastically. We haven't calculated that yet, and so it's hard to say what could happen from there. There's a lot of like vegans out there now, right? And so maybe the cheese consumption, instead of increasing this way, has sort of leveled off. I don't know. Yeah, so things definitely change. So it's hard to predict the future. Okay, there you go. My advice to you guys would be to get as much of this done as you can in class in the next 20 minutes because you guys have access to the iPads now, so you can use those. Yeah.